Chapter number 14, Descriptive Methods in Regression and Correlation. So this is a very interesting chapter, and a lot of examples and a lot of stuff presented in this chapter deals from everyday life, right? So this chapter basically consists of two topics. One is the regression and another is the correlation, right? In some textbooks, some people discuss correlation first and then regression. Some textbooks discuss regression first and then correlation. But what I will do, I will take on first the regression, then I will take on the correlation. So let's see what we have. So we start with the basic concept of correlation, right? What are the basic concept of correlation? That's what we are going to see. So before I tell you what is the correlation, we need to learn what is the difference between a univariate and a bivariate data. First, see what is the univariate data. Look at the word univariate. It's a univariate. Uni mean one, right? So what is the univariate data? A data which include a single variable, which include one variable, is called a univariate data. For example, I'm talking about the heights of the student in my class. This only include one variable, and that is the height. So this is a univariate data. And on the other hand, we have the bivariate data. And what is the bivariate data? Look at the word bi, mean two, right? Bi. Uni mean one and bi mean two. So what is the bivariate data? The data which includes two variables is called a bivariate data. For example, let's say I'm talking about the heights of the student in my class and their shoe size and their corresponding shoe size. So in this example, in this data, I'm talking about the two variables. One is the variable is the height and other is the variable which is the shoe size, right? So in this particular data set, I was talking about the two variable, so that's why it's called a bivariate data. So you should be clear about that. So far in this particular video, we have been talking about a univariate data, a data set which consists of a single variable. But in this particular chapter, for the first time in this videos series, we are talking about a bivariate data. We will see the interaction. We will see how the two variables are related to one another. Okay, so that's the starting point. Now the first question that comes to the mind, okay, so what is a correlation? A correlation said to exist between the two variables when the values of one variable are somehow associated with the values of the other variable in some way, right? The values of the one variable are related to the values of another variable in some way. Then we say there exists a correlation. I will show you in a minute what I mean by this idea, right? What I mean by this idea, I will show you in a minute. In the next slide, let's see. So we are in this chapter, we are interested in one special type of a correlation. We are not interested in every type of correlation. In this chapter, we are interested in one special type of a correlation that is called a linear correlation. Now the question that comes to the mind, okay, what is a linear correlation? A correlation is said to be a linear if there exists a correlation, and if you plot points of paired data that results in a pattern that can be approximated by a straight line, right? Let me tell you very briefly. All of you must have heard these two axes, right? I hope you must have heard these two axes, right? This is called the x-axis, I hope you remember, and this is called the y-axis. And let's say I plot any point here. I plot a point here, right? This is a plot I have pointed. This is the dot I have plotted here. I am plotting another point. I am plotting different points. These are the different points I am plotting in xy plane, and I hope you must have heard in earlier classes such a plane is called a xy plane or a Cartesian plane, and I am plotting these so many points, right? Now what happened actually, look at that. This such a diagram in which I plot this ordered pair like x comma y. I'm plotting these points here, I'm plotting these points here. Such a plot, such a diagram, such a plot is called a scatter plot. Look at that. It's a scatter plot. And look at this scatter plot. This scatter plot suggests a straight line pattern. Look at that. If there is a band of a straight line, look at this band. There is a band of a straight line. Look at this, exactly what he's saying. the data results in a pattern that can be approximated, look at that, approximated by a straight line. So there is a band of a straight line. So such a correlation in which the scatter plot, if you make such a plot, which is called a scatter plot, I will show you in this video series how to make a scatter plot by technology. But first, for the sake of discussion, let's understand that I'm making this plot. It's called a scatter plot, and this is suggesting a straight line pattern. Such a correlation is called a linear correlation. In this chapter, we will be interested only one type of a correlation, and that is called a linear correlation. I hope this idea is clear. Now look at these four scatter plot, and I will try to further explain what I mean by the values of the one variable are associated with the values of the other variable. Please look at this data point. Look at this data point. This is the x value here, and this is the corresponding y value. These are the x and the y value. This is x value, y value. Look at this value. Look at this data point. This is the x value, and this is the corresponding y value. I hope you know how to take the x and the y values in data point. Now note that the smaller x values are associated with the smaller y values, and larger x values are associated with the larger y values. Such a correlation in which this happens is called a positive correlation. Such a correlation is called a positive correlation. It means as the x values increase, so is the y value. So it means as the x value increases, the y value also tend to increase. X value increase, y value also increase. Such a correlation is called a positive correlation. Look at this. Look at this one. There is a straight line pattern. Look at that. So this is a linear correlation. And look at this data point. Look at this data point. And this is the x value, and this is the y value. Look at this data point. Look at this. Now what happened here in this situation, the smaller y values are associated with the larger smaller x values are associated with the larger y values, and the larger x values are associated with the smaller y values. If this happens, such a correlation is called a negative correlation. What happened in this situation? As x value increases, the y value tend to decrease. So these two variables are moving in opposite direction. These two variables are moving excuse me, in the same direction. We say the two variables move in the same direction. Here the two variable moves in the opposite direction. Look at here. I don't see any straight line pattern here. I don't see. There was a straight line pattern here. Look at that. There was a band of a straight line. There was also a band of a straight line. These two correlations are called linear correlation. But here I don't see any pattern, any straight line pattern. So there is no linear correlation. I would say no linear correlation. Let me add a word, a linear here. No linear correlation. Look at here. There is a pattern. There is a pattern in this one. Look at that. There is a pattern. There is a pattern. But unfortunately, that pattern is not a straight line pattern, right? So this is called a non-linear correlation, and in this chapter we are not going to discuss non-linear correlation. We're only going to discuss linear correlation, which means the scatter plot, when we make a scatter plot, it should suggest a straight line pattern. When we make a scatter plot, it should suggest a straight line pattern. So in this, the linear correlation is the topic of this particular chapter. So I already told you this is called a positive correlation, and this is called a negative correlation. Why? As the x value increases, y value also increases, or the other way around. As the x value decreases, the y value also decreases. And here also, as the x value decreases, the y value increases. These two variables move in opposite direction. These two variables move in opposite direction, but here the variable move in the same direction, right? I hope it is clear. Now let's further understand how the correlation works in our everyday life. You see, you might hear that the economic growth increases, the stock market returns also tend to increase. So these two variables move in the same direction. As one variable increases, so is the second variable, right? So we say there exists a positive correlation. Those two variables are positively correlated, or they move in the same direction. Supply of a commodity and its price, these variables are said to be negatively or inversely related. Why? Because as one variable increases, the other variable tend to decrease. It's a very famous economic principle. I hope you remember that. The supply of a commodity and its price, they vary inversely or negatively. As one of them increases, the other one tend to decrease, right? So they move in an opposite direction. So such a correlation is called a negative correlation. There is a negative correlation. Look at the third relation. The size of the human brain and their IQ score and the score on IQ test have no correlation. There is absolutely no correlation between a human brain size and his or her IQ, right? So these two variables were positively correlated. These two variables were negatively correlated, but these two variables are not correlated at all. Now the question that comes to the mind, okay, we are now talking about, we understand what is the correlation, but how we are going to measure a correlation? How, because we want to quantify, we want to measure it. For example, just a very simple example, let's say I have a fever. Right? If I have a fever and I want to measure it, what I will do, I will take a thermometer and the thermometer will tell me, okay, this is the temperature you have, right? I have something to measure my body temperature. In a similar way, there exists a correlation and we want to measure it. So there is a tool available, linear correlation coefficient, which is represented in this chapter by a small r, is used to measure a correlation, right? This is how we are going to compute that linear correlation. I will tell you later, but there is a tool available. There is a barometer available to measure the correlation, right? And that is called linear correlation coefficient, or it's also called Pearson correlation coefficient. A scatter plot helps us in understanding the correlation and is usually the first step in correlation and regression analysis. In this particular chapter, most of the time, your starting point is the scatter plot. The scatter plot will tell you in which direction you have to go, what type of relation you have, and how you are going to move. So the first step you're going to take in this particular chapter, I gave you a problem. The first step you're going to take, you're going to make a scatter plot, and the scatter plot will tell you a lot of facts about the association between these two variables. Okay, now we have a formula, we have a working formula here. This is the formula available. The linear correlation coefficient R measure the strength. How strong is the relationship, right? I will tell you in a minute what I mean by that. Right? It tells you the strength of the relationship between the paired of values in a sample. This is the computing formula, right? R equals to n times sigma xy minus sigma x times sigma y divided by n times sigma x square minus sigma x whole square root times square root of n times sigma y square minus sigma y whole square, right? This seems to be a very difficult formula. This is a computing formula. If you want to do the hand computation, you are going to use this formula. This seems to be a very difficult formula, but there is a good news is that I'm not going to require you to use this formula. Rather, I will ask you to use technology. You can use technology, which in this case, Microsoft Excel or StatCrunch. You can use any one of the technology to compute this formula. For those students who are watching these videos and they are not belongs to the class where I'm teaching a non-math major class, right? And in a non-math major class, I tend to relax my restriction on asking the student to do the hand computation. I rather ask them to do the computation using technology, and it makes their life easy. So you can use technology whenever it's suitable. And what is the command for that? The command is Corel x value, Corel x comma y values. You enter this command and the Microsoft Excel will help you. How we're going to use this command, how we're going to find the value of R, I will show you in the next video. So I hope you understand this introduction. correlation. Thanks for watching. Given age and the price data for a sample of 11 Orion's car, draw a scatter plot and compute the value of R. So in this data set, we are given the age of the car, which is represented by the variable X, and the Y, their prices, which is represented by a variable Y. And all these prices are in $100, which means this is 85. This is actually not 85. This is 8,500. This is 7,100, 8,200, which is 8,200. So if the prices are in $100 and the age of the car in year, I ask you guys to pause this video and think about it. What type of relation you can expect between the age of the car and its price? What happened to the price of the car if it gets older? Just pause this video and think about it. So I hope it should have come to your mind, as the car gets older or as there more mileage on the car, the prices of the car tend to decrease, right? So there seems to be a negative correlation. Seems to be a negative correlation between the age of the car and their prices. And now what we are going to do, I'm going to show you the similar stuff by using a scatter plot, and then I will compute the value of R, and our discussion will move on. So what I'm going to do now, I'm going to launch Microsoft Excel, and I'm going to show you how I'm going to make a scatter plot and how I'm going to compute the value of R. So let's see Microsoft Excel. So I'm already in Excel, and you can see in one of the column I have the ages of the car, and in the other column I have their prices, right? First, what I'm going to do, I'm going to make a scatter plot. So how we're going to make a scatter plot? Let's see. First, you select this data, right? And then you go to Insert. And when you go to the Insert, you have this chart area. Look at this chart area. And just above this chart area, you see these yellow and blue dots. You click on this one and you select the very first one. This is the scatter plot you have created. This is the scatter plot, right? Each dot represents a one value. Look at that. The point represent, look at that. It's 2,169. So X value is 2 and the Y value is 169. Each dot represents a data point. Okay, a data point of X and a Y value, pair of X and a Y value, right? So that's how you make a scatter plot. Now what I'm going to do, I'm going to show you how you compute the value of R. So let's bring my cursor here. There is a R. I want to bring my calculation here, so I bring my cursor here. So how I'm going to insert the formula? You go to the formulas, more function, statistical function, and now you're going to look for the command called Correl. C-O-R-R-E-L. That's the Correl command. C-O-R-R-E-L. That command will help you, that function will help you to compute the linear correlation coefficient or Pearson correlation coefficient. You click on that. Now he's asking, give me the first array, give me array 1. Array mean table. Give me the first table, first set of values. You tell Excel, you bring your cursor here, you press the left mouse button and drag it downward. What I'm doing, I'm actually copying the range, and you leave the button, the range cell address, the range address is copies here from A2 to A12, A2, A12. Now he's asking, where is your array 2? Where is your second set of values? You tell Excel, this is my second set of values. Again, I'm doing the same thing and I'm leaving my cursor. This range of cell has copies from B2 to B12, right? Now you press OK, and this value of R will come minus 0.92. I round this value to two decimal places. It is our tradition. Usually what we do, we round the value of R up to 2 decimal places. So R comes out to be minus 0.92. Okay, that's the value of R comes out to be. Now look at that. Look at the sign of R. This value of R is negative, right? This value of R is negative. And look at the scatter plot. There is a straight line pattern, and that pattern suggests a line which is falling line. If you go from right to left, if you go from right to left, the line is falling, right? Look at the pattern, straight line pattern, and that pattern is of a line that going down, right? So there is a negative, such a line has a negative slope. I will talk about that when we come to the correlation. So look at its value is minus 0.92, right? So this is the value of R, and that's how you compute by using Microsoft Excel. Now we see various degrees of linear correlation. This is a very important portion in this particular chapter. Look at this one. Look, we have a few scatter plots. Look at that. This look at the scatter plot 1. This the black dots are perfectly on this red line, right? This is the line, right? So such a correlation is called perfect correlation. Perfect. And why this is called positive? Because if you move from left to right, the line is going up. Look at the line is going up. So such a correlation is called a perfect positive correlation. And look at the value of R. It's perfect 1. Look at this one. The dots, the black dots are not perfectly on the line, but still very, very close to the line. Such a correlation is called a strong positive correlation. And look at the value of R. R is approximately equal to this symbol. This symbol means approximately equal to 0.9. Look at the third one, the C graph. This is the line, imaginary line. You can imagine a line. The dots, the black dots are not as close as to this one, but still they suggest a straight line pattern. There is a band of a straight line. Look at the band of a straight line, and the line is going up. If you go from left to right, the line is going up. So there is a moderate positive correlation, and look at the value of R. R is approximately equal to 0.4. Now we change the direction. Look at that. These black dots are perfectly, I'm trying to make it perfect, perfectly on this line. These black dots are perfectly on this line, right? These black dots are perfectly on this line, and if you move from left to right, the line is going down. Look at that. If you move from left to right, the line is going down. So this is called a perfect negative correlation, and look at the value of R. It's a perfect -1. Look at this scenario. There is a line, right? And the black dots are not perfectly on the red line, but still very, very close to that line. And the line is going down. If you move from left to right, the line is going down, and the line is going down, and the points are very close. So this is an indication of a strong negative correlation. And look at the value of R. It's negative. The R is negative. Look at this here. R was positive, R was positive, R was positive. So when there is a positive correlation, the value of R is positive. When there is a negative correlation, the value of R is negative. Look at this one. Look at this one. The dots are not perfectly on the line, but still close to the line. So this is an indication of a negative but moderate negative correlation. And look at the value of R. It's close to -0.4. Look here, the plot G. There seems to be no straight line pattern. There seems to be no, at least I can't see a straight line pattern here, right? So there is no linear correlation. So R must be close to 0. When the R is close to 0, it means there is no linear correlation. Look at this one also. Look at this one also. There is no straight line pattern, although there is a pattern. In the black dots, the dotted points, but that pattern is not a straight line, and we are not going to discuss such a thing in this chapter, right? So no linear correlation. So I hope you are able to understand these graphs, these scatter plots. It's very important that you get a very clear idea of the values of R and the straight line, these lines. Okay. Now we see some properties of linear correlation coefficient, this R. We see some of the properties of this R. Let's see what are the properties. First, the value of R always lie between a -1 and a +1. It's always lie between a -1 and +1, right? Let's see. You must have seen the speedometer in your car, right? Or not the speedometer. Let's talk about the fuel gauge, right? Fuel gauge, right? Think like a fuel gauge. This is a -1 and this is a +1, and this is the value of R. So the value of R can be close to a -1, can be close to a +1, and it can be close to 0. So the value of R always lie between a -1, a +1. Think like the fuel gauge in your car. It always lie between full and empty, between full and empty. Right, your fuel gauge, the fuel needle always lie between. In a similar line, the value of R always lie between a -1 and a +1, always. It never exceeds 1. R is never greater than 1, never, never. And R is never less than a -1, never. Remember that. It always lie between a -1 and a +1 inclusive. The value of R measure the second one, R measure the strength of the linear relationship, and its sign tells us the direction. Remember in our last example, the value of R which I computed was -0.92. Okay, now let me now you see this, a value of R contain two things. One is this sign, look at this sign, and one is this value. The sign tells you what is the direction of the relation. Is it a positive or a negative? And this numeric number tells you how strong is the relation. If this number is close to a 1 or close to a -1, it means the relation is a stronger one. And if this number is close to 0, it means there is a weak relationship. So remember, a correlation can be strong and a correlation can be weak. Remember, correlation doesn't imply causation. You cannot conclude a cause and effect relationship in a correlation. This is very important to understand this idea. Correlation doesn't imply causation. If there is a correlation between the two variables, it doesn't mean that the one variable causes the another variable. The change in the one variable is caused by another variable, because sometimes there is a third variable which is included that is called lurking variable, and that variable is causing the change in these two variables. For example, I have given an example here. Ice cream sales and the crime rate have a very strong correlation. Can we conclude that the increase in the ice cream sales causes the crime rate to go up? Now this seems to be very stupid statement. How come the increase in the temperature can cause, how can increase in the sales of the ice cream causes the crime rate to go up? What happened actually, there is a third variable. This is the thing, like this is the sales of the ice cream and this is crime rate, right? There is a third variable which is temperature, and that temperature causing the increase in these two variables. Why? Because as the temperature increases, the sales of the ice cream also increases. And it is a well-known fact that in summer, in high temperature, more crimes are committed than in winter. So actually what is actually happening, it is not the sales of the ice cream that causing the crime rate to go up. There is a third variable involved, and that third variable which is causing the change in these two things. So remember, the correlation is never imply causation. This is a very, very important fact you need to remember.